Hello students, you are welcome to this course once again, Curriculum Studies in Mathematics Education. We are going to look at the second unit of the course, and in this unit we shall be talking about subject matter in mathematics, its selection and sequencing. Let's start with the first session, and we shall look at subject matter of the mathematics curriculum. What subject matter is all about in mathematics. My name is Justice Yosin Mensah. Let's look at the objectives for the session. At the end of this session, you should be able to identify and explain the types of subject matter of the mathematics curriculum. In our previous units and sessions, we looked at the mathematics curriculum, the definition of curriculum and syllabus, and the differences between them. We also looked at the primary and JHS syllabi, the rationale, general aims, and objectives for each of them. And we further looked at the structure of the JHS syllabus. As we know, mathematics is important in all aspects of our lives. Now, what content or subject matter should be taught at what level is a question worth asking, and curriculum developers consider this matter in their development of the school curriculum. This unit, we shall focus on subject matter, that is the content that we should include in the syllabus or in the curriculum. For what level? We look at the levels in the specific subject matter that they are supposed to deal with. And then we also look at the factors influencing the selection and sequencing of subject matter in mathematics at the JHS and SHS levels. Before we continue, let's look at what we mean by the term subject matter in mathematics. Subject matter of a subject refers to the knowledge, practices, and beliefs about the subject. So we are talking about a body of knowledge, practices, and beliefs that you have about a particular subject. That constitutes what we call subject matter. Kuni et al. In 1983 says some of the subject matter of mathematics is knowledge we have about mathematics and beliefs about the relative importance and modes of application of various items of knowledge. So according to them, this is what they talk about when we talk about subject matter in mathematics. So we must take note that the term subject matter differs or is different from what we call topic, and I shall give you some explanation to that. When we say topic, is the name of a body of subject matter. So the name of the body of subject matter is what we say a topic is. For example, we can say area of geometric shapes. Area of geometric shapes is a topic. The knowledge or belief denoted by the name constitutes what we call subject matter. Example, to find the area of a rectangle, multiply the length and width. This is the subject matter of area of geometric shapes, which is topic. So subject matter provide more information, or it gives you the detailed information about a topic. Topics are usually names or phrases, so they don't form a sentence. They are usually phrases or names, whereas subject matter about a topic is expressed in sentence form. To find the area of a rectangle, multiply the length by the width is a sentence, while area of geometric shapes is a phrase. So you should take that to account. When we talk about selecting subject matter, we're usually referring to selecting the topics, then you select subtopics, then subordinate topics, and then you talk more about them. Then we are talking about selecting subject matter. Let's look at the types of subject matter. And in this session, we shall be considering three main types of subject matter in mathematics. And these are concepts, generalizations, and skills. These are the three main types of subject matter we shall be dealing with. Let's look at what we mean by concepts. When we say concepts, a concept is basic knowledge of what something is. So when we say a child lacks the concept of place value, it means the basic knowledge in place value, the child does not have it. So examples, we can say the number 10 is a basic knowledge. The number pi, a variable, circle, congruence, etc. These are basic knowledge about something. That is what we mean by concept. Having the concept of something to ascertain what its other properties are and how it is related to other objects. So if you know the basic knowledge of what something is, then now you can relate it with other objects using the properties that the thing has. Chem 1977 defines concept as way of processing data which enables the user to bring past experience usefully to bear on the present situation. So when you have the concept of something, when you are confronted with a present situation, you are able to bring that past experience or that knowledge, basic knowledge that you have, solve the problem. So in a way, a concept is an idea or mental structure of something. So this, when you have the concept of something, it is a mental structure. It is formed in your memory. And it is the basic building blocks of mathematics. So you see that if a child lacks the concept of place value, then how will the child be able to deal with that particular thing when it comes to more complex examples or generalizations and skills? The child cannot do that. So it is the basic block of mathematics. Let's look at generalizations. A generalization is a statement that is true about all the elements of a set. So when we say you generalize something, it means that it will work for everything about the set. So if you're talking about the set of numbers, you can make generalizations about that. And that generalization should be able to work for every element, every number in the set. Mathematicians make generalizations after they have studied the properties of objects and the relations among them. So you can only make generalizations if you are able to study, the properties of objects, all the objects, or majority of the objects, and you are able to say that no, this will work for all of them. For example, we say that prime numbers have only two factors, and this is true for all the elements of prime numbers. So we are able to make this generalization after studying the properties of prime numbers. Just like concepts, they are kind of subject matter that mathematics teachers teach to their students. So we teach generalization as well. So examples include every prime number has exactly two positive factors. The sum of interior angles of a regular polygon of n size is 180. The formula is there. So you can say formulas are generalizations because they will work for every element. Multiplication is commutative. The area of a circle is pi r squared, and so on and so forth. Generally speaking, generalizations are usually taught in one of two ways, either by exposition or by heuristic, that is by guided discovery method. So you can just take the formula and then you give examples, that is by exposition, or you can guide the students to deduce the formulas by themselves and then use them to solve problems, that is by heuristics or guided discovery method. Let's talk about skills. When we say skills, so just like concept and generalizations are cognitive knowledge, knowledge of how to do something is what we call skills. If you know how to do the thing, for example, you know how to add whole numbers, that is a skill. Examples are adding whole numbers, factoring algebraic expressions, measuring angles, and so on and so forth. All these are skills. Teaching skills play an important role in the teaching of mathematics. And mathematics is a practical subject. So skills play a very important role. You must teach children how to solve problems and work mathematics. Skills help students to further their mathematical learning. So if you know how to do it, then you can further it. And students obtain skills from a lot of practices and sometimes through imitation. So for students to develop skills, you must give them a lot of exercises, a lot of practice. So teachers must strike a balance between teaching these three types of subject matter, that is generalization, skills, and concepts. You must strike a balance. How do you teach the three so that students are able to use them? Ladies and gentlemen, we have come to the end of the first session of Unit 2. And as usual, I'll leave you with these questions. Look at them critically and discuss them among yourselves.